Hi, everyone. This is Sebastian Traeger, Managing Director at Reliability.com, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today, I am excited to be joined by Michael Zolotov of Razor Labs. Michael, welcome. We're thrilled to have you.
Thanks for having me. Pleasure to be here.
I'm excited to talk to you specifically because we don't always get a chance to talk to other technology companies. We ourselves provide technology, and so it's going to be great to talk to somebody else where your core business is really around technology. So tell us a little bit about Razor Labs and what you all do.
Fantastic. Thank you. Pleasure to be here. I'm Michael. I'm the Chief Technology Officer and one of the co-founders of Razor Labs. I started the company with my partners roughly 10 years ago, and we really recognized the mining sector as a key sector where our impact, having AI, artificial intelligence background, could really make an impact. And we've seen that despite the current tools that are used on site, failures still happen to equipment, catastrophic failures that have obviously safety implications and obviously financial implications. And maybe I can say that I'm the only one in my family that's not a doctor. My entire family are. And our goal is to kind of build an automated doctor for equipment, starting with fixed assets, but then also going to mobile fleets and kind of taking all of these potential failures that could happen and happen on sites today, despite current tools, and be able to prevent them. And we've built an offering, what we call AI sensor fusion, basically being able to fuse or combine together a very diverse set of sensors, just like a doctor uses, ultrasound and CT and blood work and so on, X-rays, and being able to combine it all to make sure that no failure is missed, both in fixed assets and in mobile fleets.
Excellent. Okay. Well, I want to drill down a lot more into that. Before we get a lot more into your company, and I mean, just even your summary gives me so much more I want to ask about. Just want to hear a little bit more about you. What's your, you mentioned you started this company out of your background. So what was your background? What was, and kind of what prepared you to start this company?
Yeah, so it's a good question. My background is AI. That's what I've done for both bachelor's and master's degrees. Back then, it was really more of a thing in the academia. So you could see, PhDs and, universities exploring this one, but not so much around, real world applications in production. And we started the company as basically an AI service provider. We were doing the most complex stuff around AI, whether it's in medicine, whether it's in retail, whether it's in, heavy industry and so on. And we've taking our expertise to real world systems in production. And we were looking to productize this offering in one of these sectors. And we've actually seen the mining sector both as a sector where, on the one hand, the impact is dramatic. Not many sectors you can say that, 1 hour of downtime is $100,000, $200,000, dollars per hour.
Right.
And on the other hand, not so many systems exist, meaning not so many competitors. And by taking both of these together, that's why we've made this decision to focus on this sector.
Smart. So basically, big leverage if you solve the one problem, pays for you for a year to solve one problem kind of thing. And then on the other hand, not a whole lot of other people doing that. That's really interesting. So again, I want to drill down more, but again, just to get to know you a little bit more, I know you're doing a startup, you're a co-founder, so it's not like you have that much time. You just said you were in Australia, so you're obviously traveling all around. But what do you like to do outside of work?
Be with my family. I have a 10-month-old daughter. So basically,
Excellent.
Be with her and my wife, travel around. And that's the little time that I have that I'm not working. That's what I like to do.
And just for anyone listening to this podcast who's even considering Razor Labs and their service, you got to know this guy's got to feed a 10-month-old. So he's hungry to perform for your business. He's not gonna drop the ball knowing the stakes at home. That's great though, Michael. So getting back into the business, you mentioned that mining is an industry where an hour of downtime can cost quite a bit of money. What are those KPIs that you're most solving for with your product?
It's a good question. And I would say that there are two main sorts of clients or two main groups of clients. We have the one type of clients that their goal is to just push more tons, push more recovery, every hour counts, and their goal is to increase availability and through that increase utilization of equipment. Basically more tons. These are the clients that basically the business cases that we built with them are basically how many hours did you have last year that was unplanned downtime? And these can be prevented. You multiply it by the throughput per hour, you multiply it by the dollars per ton, and you get to obviously new dollars or new revenues that you can get. That's one group of clients. I would say it is not the majority. Obviously, it depends on the commodity. Gold clients, for example, gold sites are like that. You have the other ones that their goal is to reduce costs. Their goal is to achieve the same throughput with less maintenance costs. In maintenance
Okay.
costs, you have obviously labor, spare parts, and so on. And the goal there is really about acting earlier and prolonging life of equipment. And I'll explain why. Let's say you have an upcoming failure, right? It's already deteriorating. The equipment is already deteriorating. The earlier you deal with it, the cheaper it is and faster it is. I'll give a very simple example. You have a gearbox that's not being lubricated. If you act on it early on, you lubricate it, it takes 20 minutes, very cheap, back to normal, that's it. But if you find out about it, you need to replace the entire gearbox, meaning at least shift or two of downtime, very expensive gearbox, right? If it's a conveyor and things like that, or an engine of a haul truck, very expensive. So the same issue became like 5 times more expensive just by, dealing with it later.
Yeah.
Second thing is I'm taking all of my equipment on site and I'm looking what is the lifespan of that equipment. And with our tools, you're actually able to prolong the lifespan, whether it's, for example, finding operator abuse in haul trucks, whether it's finding these, small human errors during maintenance, become much, much larger events. And by prolonging the lifespan of equipment, I'm making sure that we're replacing less equipment, which obviously each replacement costs a lot of money, less replacements, less expenses, less maintenance costs. So these are the two. Number one is more throughput, meaning more revenues.
Right.
The second is less maintenance costs.
And that's great. I am curious, which of those is usually an easier sell? Is it helping a gold mining company get more out of the ground? It's like instant dollars for them, right? And I'm guessing the maintenance side or the reduced cost is maybe it's a little harder to track, maybe it's a little harder to prove just because random events can happen, right? Or so which one do you find to be a more better business case? And I know it's a different client type.
Yeah, so from our experience, actually, they both are. Our clients want them both in the business case. Some clients give more focus to one over the other, but usually they're both there. It's more like the ratio between them might change. Usually the client says what is their focus, and we know roughly, obviously, what's the cost of a motor, what's the cost of a gearbox. We look at their historical data. We build it. We have a team of analysts that build it into a business case that has both. Right? Both maintenance costs, both new throughput, spare parts, and so on. And these are all factors that sum up to the eventual number. It's not one or the other, it's usually both.
In your experience, what ROI as what they pay you versus what they save or increase their throughput, what are most clients looking for in terms of an ROI to say, we want to work with you guys?
I can say that not even working with us, but if I look retroactively, right, with deploy system, how much time did it take for the client to return the investment? We're usually looking at 2, 3, 4 months. That's it.
That's incredible.
Because the failures are very expensive. The failures that we find, no other system can find, because by definition, we target the ones that are undetectable by traditional systems, whether they have SCADAs or historians or handheld vibration devices. All of these still, as sites know, very large portion of the failures, most of them actually, are still left undetected because sites experience these in real life despite having these systems. And when you actually sum up these failures that are found, usually in 2, 3, 4 months, you return the entire investment. And then from that point onwards, it's pure profit. That's from our experience.
That's amazing. I want to hear a case study of how this works with your tools. And because there's a hauler truck behind you in your background, and you mentioned that in one of your examples, you mentioned finding kind of, I think you said user abuse is what you called it, or driver abuse or something like that. How would your tools identify that where others would not be able to identify that?
So that's a good question. I'll split the answer. You mentioned haul trucks. I'll split the answer to two. One is the ability to diagnose failures earlier. Now, how can we do it that other systems cannot? The problem with haul trucks, or the challenge with haul trucks, is that the operational conditions are changing all the time. You're changing gears, you have higher payload, lower payload, obviously the load of the engine, RPM, everything is changing, and this introduces a lot of noise into the data. Whether these are pressures or temperatures or whatever, it is very noisy. And what happens is that because of that, Caterpillar or Komatsu are putting very high threshold, because if you put them to be lower, you will have alarms every day, which is impractical. What our system is doing is it knows the dependence between the operational conditions and the temp pressures, and it's compensating for these ones. So it's able to dramatically reduce the noise, and with less noise, you're able to put much lower thresholds and to be able to detect issues literally 3, 4, 5 weeks before CAT alerts them. And The issue is that, for example, let's take an example, a cooling temperature of the engine. So CAT has a very high alarm that when it actually happens, the engine already experienced weeks and not even a month and above of working under high temperature. Every minute of such operation is obviously reducing its life. We're finding this one much earlier, meaning longer life of the engine, meaning reduced maintenance costs. So that's one thing that we do. On top of that, we're using that sensors together with the oil analysis and the other fluid analysis and other systems, SAP and so on, to give a very deep root cause of that failure. So not just your temperature here is above 60, but rather, for example, we've taken all of these data together, your engine harness is now deteriorating. So it's a much more specific root cause with more specific actions that obviously they don't require so much investigation time, and it makes sure that the failure would also not repeat in the future, which again translates to lower maintenance costs. The second part would be, as you said, the driver or the operator abuse, or what we call the operator proficiency, to make sure that events such as hot engine shut off or abuse of the hydraulics and many others are captured. We're able to prevent these ones by training the operators, and again, these are prolonging the equipment life because they're not obviously abusing it. So these are the two components in whole trucks.
In that example you gave, though, about the high temperature running for 5 weeks and you detected earlier, what is the action step that comes out of that once you identify it?
So it depends on the diagnosis. So the way that our AI works is that it gives a very concrete failure mode, root cause, and recommended actions. And every root cause has its own recommended action given literally in plain text within the dashboard itself. So it really depends on the root cause and what's happening, whether it's a radiator issue or a leak or whatever it is.
And so your AI is effectively, well, let me ask you this question, and I don't want to assume anything. To what extent are you all training that AI to know in a hauler truck, here are the 6 potential failure modes and root causes and corrective actions? And to what extent is the AI just kind of figuring those out?
So option A, for sure. If I give a few sentences about AI and how this one works, traditional AI systems learn by example. That's the way that they work. It's not so suitable for mining because then if I use them, I would come to a mine site and I would ask for 1 million examples of their failures, right? Which they do not have, obviously. There are no million examples of a ball mill bearing failure because there's just not enough ball mills in the world. Many systems actually use this old-fashioned approach, and then they approach mine sites and they ask for the mine site for a year long of calibration and teaching and so on. We understood early on that it's just not suitable for that market. So we've went on a very different approach. It's called semi-supervision, a bit similar to how ChatGPT is trained, where basically we've assembled a very strong team of experts. With these experts, we've mapped all the critical equipment, fixed and mobile, their components, failure modes, root causes, and the patterns in the data. And these experts were able to map that, and we then train the AI what to look for. So the AI already comes with a preliminary knowledge of, if I see these patterns, it's that specific root cause, and that's what needs to be done. And because it already comes with that knowledge, just like a doctor, right? You go to a doctor, you don't teach the doctor medicine. The doctor is already aware. It's exactly the same with our system. You just, connect to the existing sensors if there are. We deploy new sensors if required. And that's it. The system is literally up and running the day after, performing the diagnosis and delivering the value. So that's a major difference in how the AI is trained, how it works, in order to actually accommodate ourselves to what's relevant to that market.
And then presumably, as you're finding new problems, it's getting trained on those new problems that you're now discovering and making it smarter. Well, which is obviously a strategic advantage of picking one vertical, because you can actually make that one vertical just optimize for that, right? And be as good as you can at that one.
For sure, I can give an example, right? In the last year, we've added, cameras to the game, and we now have cameras that are able to detect, from belt trips to misalignment to oversized ore to monitoring splices and clips in the belt. So stuff that really our clients ask for and cannot be detected by any other sensor. And for us, a camera is another sensor. We're performing the relevant measurements from that sensor. We're training it just like any other sensor, and it, again, makes sure that our coverage is really holistic. that we don't miss anything that can happen to the equipment. In this case, whether it's conveyor belt or monitoring, for example, bubbles of flotation cells and things like that.
Wow, that's fascinating. That's really great. So as you all think to the future, then, is the future going deeper like you just described? Okay, now we have cameras, now we have whatever's next, or is the future going to different industries?
So from our point of view, we started with fixed assets. We then expanded to mobile fleets, meaning haul trucks and underground LHDs. We're now also expanding to excavators and others. We're now also expanding to even tougher equipment to monitor, such as drag lines, bucket wheel reclaimers. So equipment that is very noisy, requiring ultrasound frequencies. It's something that we also now beginning our support. And yeah, the next thing would be to also, both geographically expand and also to adjacent industries, such as oil refineries, such as power plants and things like that.
Okay, but really you're saying first is let's just kind of every asset within a mine, let's get all those done so that we can be a holistic solution for the mining industry. That sounds like that's your primary target. And then once that's kind of knocked out, which obviously is going to take some time, it's like, what are the adjacent ones that have similar equipment, similar use cases? And obviously oil and gas is also asset intensive where outages are very expensive. So it makes sense strategically.
Already today, we completed our coverage of all fixed assets in mine sites. So today, there is no fixed assets that we do not support. It took us several years, but we got to that point with major deployments over this one. Just a year and a half ago, we signed a major deal with Glencore of more than $30 million across 14 of their sites globally, Australia, South Africa, DRC, Latin America, and so on. So that's been also a major growth for us. Then expanded mobile fleets, starting with haul trucks, but now also to dozers, excavators. And yeah, the goal would be to expand further and in the future to also go to adjacent industries.
Great. And our company provides root cause analysis software. Yours is obviously automating a lot of that. Where do you see the gap? And, ours automates, but it also is more kind of post-problem, let's do the investigation. How do you see, obviously your software is trying to kind of automate all that. So it's like, hey, you don't even need to do this because we've kind of figured it all out. Where are the gaps then in your mind where it's like, okay, here's where there's still going to have to be the human comes in, yes, using AI tools to kind of do that investigation?
I think that these two softwares are actually complementing one another and not replacing. For example, when I find today an equipment that's deteriorating, the next step, which is what you're doing, is to take it to improvement programs to understand not only the root cause, but how do I improve my maintenance strategy going forward?
Mm-hmm.
How do I make sure that whether it's, training the operators, whether it's understanding that the maintenance frequency in that specific piece of equipment needs to be different because of these reasons. Maybe there's a design issue. So taking this one not from only preventing this deterioration right now and prolonging the life of that specific equipment, but rather going on a more strategic level, which is what you're doing, and where humans are required today, AI is not there, really to take it to the next level of perfecting the maintenance strategy accordingly. That's the way I see it.
Good. That's good. Well, this has been a fantastic time with you. I hope all of our listeners really understand just, whether you're in mining or not, just understanding the power of AI and where it's headed. And it's just incredible to hear that, Razor Labs is already delivering value on such a huge scale in such a short amount of time with AI and obviously with just very thoughtful folks setting up sensors and solving problems. So, Michael, any last final word from you before we wrap up?
I guess that my message would be traditional AI systems were a pain to deploy, and modern AI can really deliver value. It works out of the box, just like when you buy an iPhone, it works. You don't need to teach it, or a Tesla. And I think that with these systems, the team on site can really focus on the issues that require their attention. And it also makes the operation safer, which is very important, right? You don't want to be next to equipment that is right now failing or overheating and so on. So modern AI systems are delivering real value across multiple geographies.
That's great. Well, Michael, thank you so much. Again, this has been Michael Zolotov with Razor Labs. Thank you for your insights. To all listeners, We're really about helping engineers and reliability engineers, really anyone, solve problems using technology. So if you're in the market for root cause analysis, training or software, come check out Easy RCA. If you're in the mining industry, I encourage you to check out Razor Labs. They've got some incredible sampling technology as well that can help you. But again, we want to help folks use technology well to solve problems in the reliability space. And so thank you, Michael, for sharing for how people can do that. That's all we have for today. Thanks for joining us and making the world a more reliable place. We'll see you on the next episode. Take care.